To solve LEETCODE question 314 binary tree vertical order traversal. It's a median LEETCODE question. So given the root of any binary tree, return the vertical order traversal of its nodes value from top to bottom, column by column. So there's an example here. If two nodes are the same row and column, the order should be from left to right. So if they are in the same row and the column, it should be left to right. So basically, if you look at the example that they give here, the tree, the end result, what it wants you to print is basically this 9 first, if you look at the result, and then 3, 15, and then 20 and 7. So by looking at the answer, you kind of get the idea is that the function you write is what you wanted to do is print the first line here, basically the column, everything on the first column here, and then from top to bottom. Then this second column, including 3 and 5, and the third column is 20, the fourth column is 7, right? If you take a look at the second example, so in this case, it should be 4, 9, and then 3, 0, 3, 0, 1. And then this is 8, and this is 7. And then what the requirement was saying is that if there are two numbers there, you want to print from left to right. So then the third example that it gives to you should be 4, 9, 5, and then the third column is 3, 0, 1, and then 8, 2, and then 7. So it's the tree nodes is in range 0 to 100, and the company asked this question: Facebook, Bloomberg, Amazon, Microsoft. Facebook asked it 1790 times in the past 6 months. So if you're going for Facebook, you should definitely look at this question. So think about this problem. We can look at the most easy example here. Basically, it want you to print not like only left to right, but also like the by the column. So one column, this column, the next one, right? So if we are using buffer search, the layering order is definitely there because buffer search is the printed by layer, right? If we use buffer search, then we also use our queue structure. So what we need to do is I drew a photo to make sure it's easier for you to understand here, and this is how it looks. So basically, this is something look like this. The top row that I wrote here is basically the column number, and that the left side is the row number here. So the root node, which is 3, and the column number is 0, and then the 15 is right here. And then on the left side, and the 9, the column number is -1 because it's on the left side. And the 20's column number is 1, and 7 is 2, right? And then each row, we just go down and the number goes bigger. So let's say the root number is 0, and then the 9 and 15 is at the row 1, and then the row 2, and then row 3, right? Something like this. So basically what we wanted to do is that we want to use a hash table or hash map to store the column number, and basically the key should be, let me write it here. So the key should be the column number, and then the value should be a list of everything that is in the same column. For example, 3 and 15 are in the same column, something like this. So this should be the value. The value should be a list, whatever it is on the same column should be put in the same value because their column key is the same. So you get an idea how the hash map should be looking like. And then we want to use the queue data structure. And what we wanted to do is basically append the root value and its column index, which is 0, to the queue first. And then when we popping from the queue, we want to pop the node, and also we want to pop the column index as well. So there are two value in the queue. So when we popping, each time we pop, we want to add its child. So we will add the left node, we will also add the right node. When we add the node, then we know that the column number for the left node, it will be -1, column -1, and the right side will be column +1, if that makes sense. And then all the value will also be added to the hash map while we are popping each layer by layer. And then in the end, when the hash map has everything, we want to sort the hash map by the column. So when we sort the hash map by the column, we will get 9, 13, 15, 20, and 7. So let me show you how to do this in code here. So what we wanted to do is do our hash map here, default direct list, right? And then we want to use q equals dq, and then we want to append the root value and also the column index, which is a 0, to the queue first, so that we can pop from the queue. So while queue, what we're gonna do is we want to pop the node, which is the root node in this case, and then the column number first, right? And then we want to equal queue dot pop left, and then we pop from the queue and we get this value. And if the node exists, right, what we wanted to do is we want to the column number in the hash map, what we wanted to do is continue to append the node value, node.val. And when we append the node value, we want to also append the value to the queue. So node.left, and the column number will be column -1 because the left node has smaller column number. And then we also wanted to append the right side of the column. So we wanted to say node.right here, and then the column number will be +1 in this case. So after that, we actually already have everything in the hash map already. So in that case, what we wanted to do is actually sort the result. And how do you sort the result is that map column for C in sorted, and what we want to sort is sorted by map.keys. So in this case, it will have the result sorted by the column number. So the -1 column, the 9 should appear first. Let's see. Yep, let's submit. Yep. So let me know if this is helpful, or if you have any questions. Please like my video and subscribe to my channel, and I'll see you soon. Bye bye.